Now let's look at limits of polynomial functions. So firstly, what a polynomial function is in terms of a little review. We know that a polynomial function is of the form p of x is equals to a sub n x to the power n plus a sub n minus 1 x to the power n minus 1 plus a sub n minus 2 x to the power n minus 2 and so on, right? So for example, if you have like 3x to the power 4 and then you have the next one to be 2x to the power 3, for example. So what you have observed is that you have seen that your n here is representing the 4. So the next one, our n now is our power here for the next term now is just n minus 1, which is 4 minus 1 is 3, plus maybe this would be minus 5x to the power 2, right? So this is 4 minus 1 minus 1, which is 4 minus 2, right? It's n minus 2. N is 4 minus 2. So when you minus 2 from each 4, you get 2, right? And so on. So probably the next one could just be 9, for example. So it means the next term is missing, which is x to the power 1 is missing, right? Now, observe that the coefficients are different, right? Even if they are the same, they are polynomial functions. Now, this a sub n is representing the first coefficient. The a sub n minus 1, it doesn't mean that n will be reducing by 1. No. It just indicates the different coefficients within these terms. That's what these guys indicate. So, observe that the powers of these expressions are all positive and they are not fractional numbers. So the power of a polynomial should never be a negative and it should also never be a fractional number. So for example, if you have 2x raised to the power negative 5, this is not a polynomial function. 3x raised to the power 1 over 2, it is not a polynomial function, right? So all of these functions are polynomial functions except question number 4 and question number 8. So we just want to treat them as it is, though they are not polynomial functions, but we will still solve them to give you a little insight on what we're going to do ahead of us. So now, let's solve these problems now. So we take the first one. Question 1 says, the limit of 2x squared plus 3x minus 4 as x is approaching 1. So if you were asked to just find a limit, it's easier. But if you were asked to determine the limit using applying the properties of limit, then it means that the first thing you need to do is to take the limit of each term. So you take the limit of the first term, 2x squared, as x is approaching 1, plus the limit of 3x as x is approaching 1, minus the limit of 4 as x is approaching 1. Then again, you further apply the limit. This one, the scalar rule, right? The scalar rule. So the scalar multiple rule, it means you must send this 2 across. You have 2 the limit of x squared, x is approaching 1, plus you send this 3 across, 3 the limit of x as x is approaching 1, minus the limit of 4 as x is approaching 1. Now also for this, the power rule, you have 2, now the limit of x as x is approaching 1, then you raise the whole thing to the power of 2, plus 3, the limit of x as x is approaching 1, and then minus the limit of 4 as x is approaching 1. Now you can apply this thing as far as even, you can apply this one as far as this point right here, right? But we just want to apply all of them together, that's all. But it doesn't matter when you apply it. As long as it reaches to the stage of applying the limit of x, you can apply it. So now, in this case, now we want to apply the limit. The limit provides that x is the function, and then you have the variable within this function, x is approaching 1. So as x is approaching 1, what becomes of the function x? So now we have 2. Whenever you are applying the limit, now you are replacing this x in there with the value that is given. You no longer carry the limit. So we drop the limit now, and then we just put x value, which is 1, raised to the power of 2, right? Plus 3 now, you put 1 right there, you have 1. Minus, now the limit of a constant, we told you the limit of a number is just equal to the number. So there is 1 square, which is 1 times 1 is 1. 1 times 2 now is 2. 3 times 1 is 3 minus 4. So this now is 5. 5 minus 4 is just 1. So all of these values in red, all of these numbers that are circled in red are all of their answers. Now let's take the next 2 examples. So the next one says that the limit of x squared plus 3x plus 5. Now, since we were not asked to solve these limits or to find each limit using the algebraic properties, we can directly find each limit if they exist. Now, so we replace each of these variables with what x is approaching. So because x is approaching 0, we want to know what will be the limit of this function. So if you replace this one with 0, you have 0 squared plus 3 times 0 plus 5. So this is just out, you have 5. So when x is approaching 0, the limit of this function will be equals to 5. That's how simple and short it is. The next one, when x is approaching 2, what becomes of this function? You have 3 times, you put 2 raised to the second power minus 3 times x, you put 2 again, plus 4. So this is 3, 2 times 2 is 4. 3 times 2 now becomes 6, or plus 4. 3 times 4 is 12. Minus 6 plus 4 now is minus 2. 12 minus 2 is 10. So when f is approaching 2, the limit of this function now goes to 10. Now we take the last 3 problems selectively, and then you can now practice the rest of the other problem. So we take number 4. Remember I told you number 4 is not a polynomial function, but let's just apply the limit. So we apply the limit. Right here you have the root of this is the cube root, remember. This is x. Now x is 4. 4 plus 4 is now equals to the cube root of 8. And we know that 8 can be rewritten as 2 raised to the 3rd power, which of course the cube root will cancel. You just left with 2. Now this one, we replace t now. Now this is, you cannot have, now look at now. So we have the limit of t plus 1 raised to the 9th power times t minus 1. If this thing is x, if this thing was actually x, it means t is a constant. If it is x, then it means t is a constant because the variable of the variable that we need to apply is x. But this thing was actually t. It was a slight error. It was actually t. So since now this is now t, so t now is not a constant any longer. T is a variable of the function. So we replace t value now with minus 2. So you put minus 2 here, you have minus 2 plus 1 raised to the 9th power times minus 2 minus 1. So minus 2 and minus 1 now is minus 1 raised to the 9th power. Minus 2 and minus 1 is minus 3. When the power is odd, it means it will end in negative. When negative 1 is raised to an even power, 4, 2, 6, it will just be equal to positive. When it is raised now to an odd power, 3, 5, 7, it will be equal to negative. So because it's odd, it's negative. Times negative 3. So you have -1 times -3, it just equals to +3. So we'll do the last one. So now we're going to replace this x now with -1/2. So it's 9 minus 1/2 raised to the second power minus 6 minus 1/2 plus 3. So 1/2 times 1/2 is +1/4 minus, now negative times negative is positive. 2 into 8 is 1 times, 2 into 6, 3 times, so it's +3 plus 3. So this and this will give us 6. Now this is 9/4. So the easiest way, 4 times 6 is 24. 24 plus 9 is equals to 33/4. So that's how we got our answer.